Hi, this is the video for the key for the on-level Module 1 CBA review. So we will go through all the problems so that if you have any questions you can ask in tutorials. Up here are the skills you should be able to do by the time you get to your CBA. So the first one is that you can represent factors and multiples. You can determine factor pairs using arrays and area models. You can distinguish between prime and composite numbers. You know your divisibility rules. You can determine prime factorization of a number, determine least common multiple of two numbers, and determine greatest common factor of two or more numbers. This vocab, it does not have to be memorized. You don't have to have the definitions completely, memorized to you, that they're going to come up and ask you a specific definition on the CBA. That's not going to happen. You just need to know what they mean. So we'll go ahead and jump in and get started. The Venn diagram below shows multiples less than 100 for 18 and 12. So we're looking for multiples less than 100, 18, and 12. Right, this Venn diagram, it didn't do a very good job of labeling, so this is actually going to be for our 18, and this is going to be for our 12. In the middle is where we're going to have our common multiples. That's what CM is going to stand for, common multiples. Based on this information, which of the following statements is not true? So this whole not needs to be highlighted because it's important. So not true. A, 72% is the greatest common factor. Okay, this question is tricky, this answer choice, because 72 is the largest that is the common, but we are not talking about factors. We are talking about multiples. So if that had said multiples, that would have been true. So 72 being the greatest common factor, that's not true. Okay, 18 has 5 multiples less than 100. Well, we can count 1, 2, 3. We also have to include the common multiples 4, 5. So this is true. 36 is the least common multiple. That is true. It's the smallest of the common multiples. 36 would be the least common denominator for 1/18 and 1/12. This is true. If I was trying to make equivalent fractions for these, I would want to use the least common multiple as my new denominator. So I would write that as 36 over 36. This would become 236, and this would become 336. Those would be my common, or my equivalent fractions for that. So that would be true also. So the correct answer, because it is not true, would be A. So be really careful on that. It had really tricky wording. Number 2, the Venn diagram below shows the multiples less than 100 for 20 and 15. So we're still talking about multiples. We've still got less than 100, and we've got 20 and 15. Okay, and this one is better. It's labeled 20 and 15. Based on the Venn diagram, which of the following statements is not true? So that not is going to be a big important word for us. So when we look at this, A, 15 has 5 multiples and 20 has 3. So 15, 1, 2, 3, 4, 5, but we have to count the middle, the common multiple. So 15 actually has 6. And 20 has 1, 2, 3, 4. So A right now, not true. B, 20 and 15 only have one common multiple. There's only one in the middle, so that is true. C, the overlapping area represents the common multiples. That is also true. They're the ones that they share. So A would be correct because it is not true. Number 3, the Venn diagram below, that should be above. Venn diagram above shows the factors of 24 and 36. Based on the Venn diagram, which of the following statements is not true? So again, you guys are getting a lot of not questions on this review, so make sure you're paying attention. The greatest common factor of 24 and 36 is 12. Well, if we look, this is my 24, this is my 36, and the greatest of the common is 12, so that is true. 9 is a factor of 36 and 24. If you notice, 9 is only in the 36 side of our Venn diagram, so right now that is not true because it's not a factor of 24. C, 36 has more factors than 24. Well, 24 has 1, 2, 3, 4, 5, 6, 7, 8 factors. And 36 has 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is true. D, 24 and 36 have 6 common factors. There are 6 in the middle right there, so there are 6 common factors. That's true, so our correct answer would be B, because it is not true. Number 4. At the ballpark, they are giving free baseballs to seat sections that are divisible by 2, 3, 6, and 9. Help the following families determine if they will receive a baseball. So for this, to help us out with our divisibility rules, what I like to do is I like to just kind of write above what each one is, just in abbreviation form. So for divisible by 2, I'm just going to write even. Divisible by 3, I'm going to put sum, because the sum of the numbers has to be divisible by 3. For divisible by 6, it needs to be divisible by 2 and 3, and for divisible by 9, it needs to be the sum is the divisible by 9. So the sum of the numbers has to be divisible by 9. The Snyders, a family of 7, this is extra information, we don't need that, it's not important, are seated in section 72. So 72 is even, so it's divisible by 2. Divisible by 3, 7 plus 2 is 9, so it is divisible by 3 also. Because it's divisible by 2 and 3, it's divisible by 6. And 7 plus 2 is 9, which is also divisible by 9. So this is divisible by all, so they're going to get a free baseball. Mr. and Mrs. Dooley are seated in section 58. Even, so it's divisible by 2. 8 plus 5 is 13. 13 is not divisible by 3. Since it's not divisible by 3, it's not also not divisible by 6. And 13 does not equal 9, or is not divisible by 9, so it's only going to be by 2. So they are not going to get a baseball because it doesn't work out. It's only 2. The Heredia family of 10 people, that's extra, are seated in section 60. Okay, this is 2 because it's even. It's 3 because 6 plus 0 is 6, and 6 is divisible by 3. Because of that, it's 6 also. Where we stop here is it is not divisible by 9 because 60 doesn't add up to something that's divisible by 9, so this is 6 only. 2, 3, and 6 only. So the correct answer would be A. It's just the Snyders that are going to get a free baseball. Can't turn the page. Okay, number 5. Which expression or expressions shows an equivalent expression using the commutative and associative property 8 plus 11 plus 8? This was a tricky question because it didn't really explain up here. It didn't give you any parentheses to help you with the associative property. So Ms. Castillo and I talked, and we decided that all of these would work because they are all showing a change of either order, which is commutative property, or grouping, which is associative property. So a change in order is the commutative, and change in grouping is the associative, which means a change in your parentheses. So because it's happening in each one, we said that every answer was correct. Number 6, of the following expressions, which shows the correctly written property? So again, commutative is going to be, is going to be a change in order. An associative is going to be a change in grouping. And it's really good, guys, to go ahead and write. You can jot notes even on the side of your CBA just to kind of help you in the question so you don't forget stuff. So, associative, this is a change in order, which is not the associative property, so I'm going to go ahead and cross that out. The identity property, that's one that we filled out on our foldable, and it says that anything times 1 will be itself. So this is actually true. Even though it's not one of our main ones that we use a whole lot, it is a true property. Associative property here, the grouping has changed, and it changed correctly, so this is good. Commutative property, this one has grouping changing, which is not the commutative property, it's the associative property. So your correct answer is going to be 2 and 3, and if you notice, that would be answer choice A. Okay. Number 7, which property or properties were used to simplify the below expression? The expression is 2x plus 4 plus 5x. Don't panic because it's something like 2x and you haven't seen that before. That's okay. We're not even using the x's. We're just using it to simplify. So from this step to this step, yes, we added parentheses, but there weren't parentheses already in this step that changed. So this is not going to be a change in the associative property. There would have had to have been parentheses around like 2x plus 4, and then it moved for it to be counted. Since it's just a change in the order, we switched 5x and 4. This is actually just going to be the commutative property, which is A. Number 8, you are a math teacher who has assigned the following problem to your class. The work of 3 students is shown in the image below. Find out if each student answered the problem correctly. If a student didn't answer the problem correctly, write the student a note explaining what he or she did wrong. So we're looking for prime factorization. What I would tell you to do is go ahead and find out. They're all doing it for 80. So I'm to the side real quick going to do the prime factorization for 80 just so I know what correct answer I'm looking for. So I'm just going to go down my factor tree until I have only primes left. So I have 1, 2, 3, 4, 2 to the 4th power times 5. Okay, so it looks like right here, Tyler has the correct answer. I'm going to check his work. He's doing a division ladder. So he has 80. He says 80 divided by 2 is 40. 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5, and that's what's left. So he has 2 to the 4th power and then times 5. Brandon has 2 to the 5th power times 5. So I'm going to look at his factor tree. And if you notice, right here is where Brandon has an error. He has 8, and he factored it down to 4 times 4. But 4 times 4 is 16, not 8. So this should be a 2, which would get rid of our 2's here. Then I would have 1, 2, 3, 4 2's, and a 5, which would put it as 2 to the 4th power times 5. Okay, so that's the end of number 8. I'm going to try and finish this real quick. I've got a meeting, so I'm going to go a little bit quicker, but I will still explain everything. So Freddie wants to determine if the following fractions are equivalent. Which of the following strategies could he use to determine if they are equivalent? There is actually no correct answer to this, but the way we could make an answer correct is we could list the factors of 6, 12, and 18 to determine the least common denominator. We're going to change this word factors to list the multiples. If it said list the multiples to determine the least common denominator, that would then be a correct answer. B is not correct. It doesn't make sense. C, list the numerators to determine the least common denominator. Numerators and denominators you don't list one to find the other. And D, list the multiples of 6, 12, and 18 to find the greatest common factor. If we said to find the least common denominator, that would be the correct answer. So really this one, A, is probably the one we would want to focus on because it's the closest to the correct, so we would need to list the multiples to determine the least common denominator. Number 10, order the steps to compare the fractions. So the first thing we would need to do is list the multiples to find the least common denominator. That's going to be step 2, so that's going to be the first thing we'll do. Then when we change our denominator, we also want to change our numerator. So we would change each fraction to its equivalent, which would be step 2. And then step 3 would be to finally to order them in the right order, either least to greatest or greatest to least, depending on what you're asked. So we're going to do step 2 first, then step 1, then step 3, which is answer choice B. Leslie listed the greatest common factors of 6 and 18 as 3. Why was her answer incorrect? 3 is the least common multiple of 6 and 18. It's not. The least common multiple would be 18. That's not correct. 6 is multiplied by 3 is 18. This is true, but it really doesn't have to do with anything with what we're talking about. 3 is a factor of 6, but not 18. Well, 3 times 6 is 18. Oh, no. So, therefore, 3 is a factor of both. So, that's not correct. 6 is the greatest common factor of 6 and 18. This is the correct answer. 6 is the greatest common factor for 6 and 18. The set of factors below shows the common factors of which set of numbers. So, all of them are going to have a factor of 1, so we're not really going to look at that. All of them are even, so they'll all have a factor of 2. Okay, so now we have to look for 4 and 8. 8 has both. 12 doesn't have both. 12 doesn't have 8, so it's not going to be that factor. So that's going to be A. 16 has both. 32 has both. 42, 4 is not a factor of 42, so that's not going to be the correct answer. For C, they all have 4 and 8 as factors, so that is going to be correct. And then if we went on to D, we would find that 20 does not have a factor of 8, so D would be incorrect. So C is my correct answer. Alright, a math tutor asked his 3 students to find the prime factorization of 200. He asked them each to explain his or her answer. Please circle the student's name that's correct. So the first thing I'm going to do is I'm going to do my factor tree for 200, which I'm going to do 20 and 10, 4 and 5. This is going to become 2 and 2. Prime, prime, prime. This is going to become 2 and 5, prime and prime. So I've got 2 to the 3rd power times 5 to the 2nd power. So I can cross out Lauren because she has an addition sign here and it's a multiplication sign. Both Rudy and Ashley have the same answer, so they're both correct in their prime factorization. Now I need to go look at my explanation. So Rudy says that we need to multiply 2 times 3, which equals 6, then multiply 5 times 2. Here's where the error is. Multiply 2 times 3. We need to multiply 2 times 2 times 2. She also says multiply 5 times 2. We need to multiply 5 times 5 and then multiply those together. So this is not a correct explanation. For Ashley, multiply 2 times 2 times 2, which equals 8, then multiply 5 times 5. This is correct, so Ashley has the right explanation. So it's more than just looking at the prime factorization. We have to look at that explanation. And the last question. Marco is in elementary school. His father is 30 years older than Marco. His mother is 4 years younger than his father. The ages of Marco and his mother and his father are all prime numbers. What are their ages? So I'm going to list 5, 6, 7, 8, 9, 10, 11 because those are all prime numbers, or all numbers in elementary school. I'm going to cross out my composites. 35, if I add 30, is not prime. I'm going quick, guys, because I'm going to run out of time. 37 is prime, but when I subtract 4, I get 34, which is not prime. Nope, I don't get 4. 33, which is still not prime. 11 would be, add 30 would be 41, which is prime, and then 37, which is prime. when I subtract 4. So 11 would be the correct answer for Marco. If you have any questions, come in tutorials.